Hello, and welcome to this video introduction to the University of Plymouth's Computer Science degree. In it, I will take you through some key features of the degree, talk about how it works, what you'll learn, and tell you why you should study this degree at Plymouth. My name is David Walker, and I'm a lecturer in computer science at Plymouth. I'm also the program's manager, which means I'm responsible for ensuring that all of our computing degrees, including this one, are running smoothly. I teach a range of topics that are based on my specialisms in artificial intelligence, web technology, and software development. On this degree, I lead a second year module that would expose you to the ideas and concepts relating to artificial intelligence. I'll talk more about that later. Let's start with an overview of the program. Like all of our courses, our computer science course is structured into 4 years. I'll talk more about each stage in the coming slides, but for now, here's an overview. Stage 1 is intended to allow you to get up to speed. We don't require any prior knowledge of computing or programming, so this year is really to get all of our incoming students upskilled to the same level. Once you've got a bedrock of computing knowledge, we start to apply depth to your studies and delve deeper into some of the exciting and topical subjects within the field in your second year. At this point, you will also do a team project, which will develop the co-working skills that are vital to a career in the computing industry. It's important to note that the first year and the first half of the second year are shared between our computing degrees. Once you get to the halfway point, you specialize and only study modules on computer science topics. This builds in a degree of flexibility. If you decide you would like to tailor your studies towards one of the other degree courses, then changing is easy, as you won't have missed any content. All of the shared modules include degree-specific content, so you continue to specialize on your chosen degree in those early stages. Stage 3 is an optional placement year. This isn't something that you have to do. It's fine to do 3 years of study and then graduate, but we do strongly recommend students undertake a placement. Working in industry for a year has a range of positive effects on both your studies and employability. In the final stage, we continue your in-depth exploration of advanced computer science topics, providing you with a wide base of expertise to allow you to operate professionally in the computing industry. You'll also undertake a final year project. Let's look at each stage in more detail. Each year is split into 2 semesters. Each semester contains 2 modules, and we run a project module across the year at each stage. Semester 1 begins with a module on software engineering in which we teach you to program. As I've said, no prior programming knowledge is expected or required. We teach you from the ground up and have a strong track record of turning out excellent programmers. That said, if you have programming experience, then you can expect to be stretched. This module is designed to cater for both crowds. Computer systems teaches you about how computers work at the operating system and machine level. You will learn about computer architectures, all of which is vital if you're going to work in computing. In semester 2, you study cybersecurity and networks. The world is becoming more and more interconnected, and so understanding the underlying technology that enables this and ensuring that while doing so, users and their data are safe is a really important aspect of your degree. All of computer science is built on the ideas coming from algorithms, data structures, and mathematics, and you gain some exposure to this in semester 2. You'll learn about algorithmic design, efficient data structures, and learn how to use this knowledge within your daily computer science work. Across the 2 semesters in the first year is the computing practice module. This module is an all-year project and is designed to draw on all of the knowledge you've acquired throughout the year, as well as providing skills in other areas. Following industry-used software lifecycle models, you will produce a substantial computing project within your first year, an early demonstration piece for your portfolio. Stage 2 picks up where Stage 1 leaves off and begins with an advanced software engineering module. If the first year taught you how to code, this module will teach you how to code well, learning about the principles of software development and how to build software to a commercial standard. Software is usually nothing without its data, so we'll also provide an in-depth study of databases in information management and retrieval. You'll learn how to construct a database, query it, and connect it to an application. In semester 2, you'll learn about artificial intelligence. AI is currently taking the world by storm, and if you're interested in a technical career or in the societal impact of computing, then this module will be of interest as you learn about machine learning, optimization, knowledge representation, as well as the ethical considerations of the impact of AI. Our Embedded Systems and the Internet of Things module provides you with an understanding of how to write software for non-traditional computing devices, such as driverless cars, and smart home assistants that are becoming increasingly popular. Across semester 2, you undertake a group project. This involves the construction of a substantial piece of software in which you work together in a team to achieve. The aim of this project is again to draw on the skills you've learned in year 2 in a holistic way, but also to give those students going on placement exposure to how they will be working. Some students worry about the idea of group work, but it's always impressive to see how well the groups come together and what students realize that everyone can provide a valuable contribution to a team. As I've already said, the placement year is optional, but we strongly recommend it. Students work in an IT role within a company, gaining valuable experience of what their future career might be like. While it's up to the student to find the placement, the university provides support in both finding and obtaining a placement. While you're on placement, you will have visits from a placement tutor, one of the lecturers from the computing subject group. We come along and make sure that everything is going as it should, and that your education is being supported so that you gain valuable experience. Doing a placement can have an extremely positive effect on your studies and your career prospects. You come back from the placement to complete your final year having learned to work. We often find that our final year students who have done placements stick to office hours, spending a working day in the lab working on their coursework and project. Our statistics show that the result can be an uplift in degree classification, that you really can reap the benefits of doing a placement very quickly. Your career prospects are improved. You have demonstrated that you can hold down a job within the industry that you're looking for employment in. This tells potential employers that you can work and makes you less of a risk for them to appoint. You may even find that your placement company wants you back. We've had students in the past come back with job offers for when they graduate, as well as offers for financial support for their final year and final year project ideas. It really is a valuable opportunity that I hope you'll consider. The final year gives you opportunities to study the topics that will really prepare you for work, which you may well be doing within a few months of studying these modules, all being well. Semester 1 begins with a module in which you learn how to tackle complex computer science problems using GPU technology. A key component of AI is machine learning, in which tools are constructed that can make predictions based on historical data. You'll learn how these tools learn and find out about cutting edge innovations based on machine learning that really are changing the world for all of us. In semester 2, you'll learn about some of the innovative ways in which computing technology can be used, from novel applications of computer science to different programming paradigms. This module will greatly expand your computer science horizons. Advanced computing and networking infrastructures was designed in order to teach you about what the internet will be like as you commence your career. Innovations come quickly in this fast moving field, so cutting edge knowledge about how the internet works is a must. Alongside these modules is the final year project, which runs for the whole year. Here you will work on a substantial computer science project that draws together everything you've learned during your time with us. You will use computer science to solve a problem, and that problem and the way in which you tackle it is up to you to define. You'll be assigned a project supervisor who will ensure that over the course of the year you produce a piece of work that really showcases your skills. Students often say this is the most enjoyable part of their degree, and it's something that employers will ask about during interviews. So a good final year project can really help to sell you to a company. At the end of the year, we hold the final year project showcase and invite our industry partners along to see our students work. It's not unusual for job offers to happen at the showcase, so a good project can be a great way of getting a graduate level job. Our computer science degree covers everything you would expect from a computer science course. What you get from doing that at Plymouth is the benefit of a course that's based on the world-leading computer science research conducted here. The computing subject group has two large research groups, one on artificial intelligence and the other on security and networking. In the last research exercises run by the government, the majority of Plymouth's computer science research was rated as internationally recognised. As you've seen now, these topic areas play leading roles in the curriculum. This means that you're being taught by people who are leading innovation in computer science. All of the academic research group members lead modules on the course and all are actively involved in teaching their research expertise. During the final year project, you can get involved in that research. Our degrees have a substantial industry base. The courses are developed in discussion with an industry advisory panel, and some of the big names in computing, such as IBM, Google, and Microsoft, are involved. Our curriculum is based on the current state of the computing field with an eye on where it's likely to go in the coming years as you begin your career. We constantly revise the programs to ensure they remain on the cutting edge. So, how are you actually taught? What is it like to be a computer science student at Plymouth? The program is intended to reflect a working week, with each of your modules requiring approximately 12 hours work a week. Some of this time is supported, for example, a 2-hour lecture and a 2-hour seminar or workshop each week, in which you'll learn some theoretical topics in the lecture and then put them into practice in the lab or seminar. The remainder of the time is for you to complete set exercises, coursework, engage in group meetings, and undertake independent study around the topics. All of our work is assessed by coursework or practice. An example of a practice assessment might be a presentation or a demonstration. We have no exams, as we look to assess you with authentic activities that reflect how you will work in industry. All of our teaching material is available through our digital learning environment, so it can be accessed at any time. Any specialist software or equipment is provided through our dedicated labs. So that's a brief introduction to the computer science degree program. As I hope I've conveyed, studying this degree will prepare you for a career that can take you anywhere in the computing field. Our graduates go all over the world and make successful careers for themselves based on the strong foundation we've given them here at Plymouth. Thank you for watching, and we hope to see you in Plymouth very soon. If you would like any further information about applying to this course or one of our other computing degrees, you can contact the university's admissions office at admissions@plymouth.ac.uk. If you'd like any more specific information about the course, you are welcome to email me at david.walker@plymouth.ac.uk.